Good afternoon. Great talk so far. Hope you can stay awake while we talk as well. As you said, I'm a manager in charge of all the equipment and systems used for dispersing information and collecting cash, basically, from those traveling. Two of us on stage, my colleague Love. I'm a manager, so I don't really know anything, which is why we're two. I'm here more or less to set the background or the context. See if we get this working. So, Skånetrafiken is the public transport agent in southern Sweden. We have a lot of buses, we have a lot of trains, a lot of people traveling with us, some 250,000 people or trips per day. Now, we have a goal, an official goal, to double the number of trips per day by the year 2020, the base year being 2006. Now, we have seen a lot of growth, but we're not there. And the truth is, we won't get there unless we manage to attract new types of customers, new people using our systems. Basically, those who need to travel by bus or train are already doing so. And by need, I mean not owning a car or maybe not having enough income to own a car. If we're going to continue growing, we need to attract other types of travelers, people like yourselves. How many took a bus? Great. Well, actually pretty good. I'm impressed. My boss in the back.
I used to bike.
Even better. Even better. We need to attract those who don't feel they have the need to use public transport. And that could be either by developing different types of services that make your actual time on the road or in the train more valuable. But one of the biggest problems we have is to make it more accessible. Make it easy to find where is the bus? Are there buses? How does it work? How do I pay? I was talking to a colleague in the business here right before we started today's seminar who said, I don't even know how to pay. And obviously you're not going to use the service if you don't even know how to pay. Now, to set some background, most of you, how many here have a yo-yo card? How many of you think this is a state-of-the-art system? There is an answer. Sometime back in 2002, Skånetrafiken, together with other regional public transport agencies, started to consider what would the future be? What do we need to develop to have a working solution for ticketing? The system, the procurement process started in 2006. It was delivered in 2009. And we actually signed off the delivery in 2014, so it took some time before we were happy. And it's supposed to be used until 2020. 2020. 18 years. A lot of things happened in those 18 years. 2005, they started having, Velos in Lyon. 2007, Steve Jobs held up an iPhone. Bluetooth was developed here. I mean, the world is changing. If we're going to buy technology the same way we buy trains or build huge infrastructure solutions, we're not going to be able to give you what you want. I mean, this system, when launched, was very popular. Now it is considered to be a catastrophe. It's still the same system. So we have changed our perspective of what we expect. Now, how are we going to achieve this? Well, Love is going to give you some examples of projects where we're using technology from here to change and make the technology more accessible and make the trip more accessible.
Yeah. Thank you, Patrik. My name is Lindqvist and Love Månsson, and I'm a systems developer at Skånetrafiken. And Bluetooth beacons is one of the areas that are very much in focus now within public transportation, both within Sweden and also in our neighboring countries. And we have a few ongoing projects evaluating beacons with different uses for public transport to enhance and simplify the traveling experience for our customers. And I'll show you 3 cases where we're looking into the benefits of using beacons. But first, I'll go through short what a Bluetooth beacon is. It's a device using the Bluetooth low energy technology to broadcast small data packets continuously. It doesn't care if anyone receives them. It doesn't need any pairing with any phone or other Bluetooth device. And it's also designed often to fit in a very small form factor and be battery powered. And for us, that's a plus because it's easy to install in a bus or a train. You can put them in easily accessible places behind vents or roof panels. And you can change the battery in conjunction with your regular vehicle maintenance. But however, since it's battery powered and by design is always on and broadcasting things, it has its limitations. The range, for instance, is not really that amped up since it would drain the battery instantly. So typically there's a range of 10 to 15 meters for a beacon in an ideal condition. There are two major players in beacon standards. One is the iBeacon standard developed by Apple, and the other one is the Eddystone standard developed by Google. They're pretty much similar in what they offer, but the Eddystone standard is a bit more open, whereas the iBeacon standard is a bit more specifically geared towards Apple devices. But any device, any user device could use both kinds of beacons, even though the operating system might interpret them somewhat differently. Since we're using Bluetooth Low Energy, it's also low power consumption for the end user. And we see more and more phone manufacturers separating the Bluetooth Low Energy modules from the regular Bluetooth modules. So for those who always turn off Bluetooth to save battery, you would still have the Bluetooth Low Energy module on, so we would reach even more customers. And that's a quick glance of what beacons are, and I'll move on to the first beacon application, which is positioning of travelers. Now, during the spring of this year, we ran a project which we called Lighthouse, which was a part of a Vinnova-sponsored initiative called Points of Interest. And the Points of Interest project was aimed at evaluating beacons to identify at points of interest. This was a collaboration between Skånetrafiken, Malmö University, Trivector, and Fujitsu. And one of the focus areas of the Lighthouse project was positioning of travelers. So beacons were placed in stop signs at the stop points at Malmö Central Station and along the route of Line 5 in Malmö. And after some tweaking of distance calculation algorithms, we could have a test version of our trip planner app to notify the user when he was in proximity of a bus stop along his route. So as you see here, it goes green. And this is a useful feature in larger junctions like Malmö Central Stations, where there are like bus stops A through J or something, to be able to be notified when you are at the actual correct Malmö Central Station stop. And also, if you're in an unfamiliar area and you reached a bus stop that's named the correct name, but you don't know if you're on the correct side of the road. And the evaluation of the Lighthouse project was that everyone that used it thought it was very good and something that we should implement straight away. So we're currently doing a pilot with a battery-powered stop sign manufacturer. So we will launch about 100 battery-powered stop signs with the Bluetooth-enabled functionality during Q1 next year. The second beacon application I would like to mention is positioning of buses. Today we use a combination of GPS signals and an odometer that calculates the distance since the last stop. And having GPS and odometer gives us a pretty exact location of the bus, but they have their weaknesses. GPS, for instance, if you're surrounded by tall buildings or trees, you have a quite wide error margin. And if you have a road construction, the odometer count isn't that reliable. So we thought that if we fit buses with a Bluetooth receiver somewhere, maybe near the front door, we could have a pretty precise position of the bus if we use the beacon-powered bus stops that I mentioned just previously. Also, since electrical buses are more and more becoming a thing, We also have the new possibility for indoor bus stops, like the Teknikgatan bus stop at Chalmers in Gothenburg. They have their electricity line. And at the indoor bus stops, you don't have any GPS position of the bus. So there, the beacon and Bluetooth in the bus could be used to complement the odometer for more exact reading. In the Lighthouse project, we also did trials with a car going back and forth, the line 5 in Malmö with a mobile phone in it, to see how many of the stops we could detect. So the car started going slow, and as the trials went along, we increased the speed of the car. And we could see that for speeds up to 60 kilometers an hour, we had 100% accuracy going past the bus stops and registering the beacons. So this is definitely something we'll be developing further. And now for the last application, fare collection. So we're currently doing a project to evaluate using Bluetooth beacons for automated fare collections. This project will evaluate what's been done by others in the past, what others are doing right now, and how this could be also a technology enabler for other Skånetrafiken projects. In late 2015, another Vinnova project called Minimum Viable Device, or MVD, was concluded here at Mobile Heights. And that project's goal was to be able to exactly pinpoint if a user is on board a bus or not, using Bluetooth beacons and also the activity manager in the phone. And that project had an accuracy of 97%, so that's definitely something to further develop. We're in this program, we're mainly looking at two different kinds of fare collection. One is a check-in, be-out system, where when the user with his phone boards the bus, he gets some kind of notification that you've boarded the bus. Do you want to purchase a ticket? You do that, and once you leave the bus and you don't have a connection to the beacon anymore, the trip fare is calculated. And the other system we're looking at is a be-in, be-out system, which requires no interaction with the user whatsoever. So when the phone is certain that he's on the bus, he starts a ticket purchase, and when exiting the bus, the fare price and distance is calculated. Now, obviously, this needs a bit more thinking, since we don't want to bill anyone that goes near a bus or a train by accident. And what our PTA partners Ruter in Oslo is doing at the moment is they have trials with beacons on buses and payment in apps, and they wait until they've traveled 100 meters before starting the trip and the fare calculations. So they say that, well, if he's been close to the beacon for 100 meters, that's a good enough indication that he's actually on the bus and just not walking by. And knowing when a customer has entered and exited a vehicle could also be used, for instance, for incentive programs. If you could get a bonus for each kilometer traveled or CO2 emissions saved and so on. And these are the three kinds of beacon uses that I wanted to present today. And thank you for listening.
Thank you very much. Just want to ask one question before I let the audience in. When you use this, you have a lot of data, and you have built a system that is obviously hopefully working and being more efficient to the users. How open is it? Is it an open platform to add services to? We were talking a little bit about that when we were talking.
We have. For those of you who dug into our website, we have a quite old API for doing trip searches, and we're talking with our suppliers now for like an API 2.0 with extended functionality and more adapted to 2016 standards.
So other, bike companies they could add something to your services that could be used for the service towards the consumers.
Yes, exactly. They could build their own applications using our data and our APIs to tie into their whatever they are doing.
We have a question right here.
This is just because I'm working with the project with visually disabled people and their ways of navigating or not navigating in the open space and in-house. So my question is, have you thought of how to use this technology, which seems to be a good platform, for actually helping blind people, for example, to utilize? Because they're about 1% of the population.
Yeah, I mean, there are ways to use beacons for more exact positioning. You can look at the receiving power and so on, so you could get a scale of how close you are to a bus stop, for instance.
This isn't only a technological issue, it's also a question of what kind of concepts you want to develop. And actually, when we've been looking at how we want to change the experience of a customer or a person on a bus, we've posed that question. What would a blind person do, or what would a deaf person do? And actually, if you travel a lot and you go to cities where you have never used public transport, it is a little bit like being disabled to a certain extent, because you don't know how to read the signs, you don't understand where you are, you don't know when to get off, in what direction, and so on and so forth. And also, as a public authority, obviously, any kind of disabilities need to be accounted for, since we want to be welcoming for everybody.
Thank you.
Do we have one more questions over there?
Hi, my name is Jonas. I'm from Anima in Malmö. The time to implement new systems and buy new system, being a public entity, what are the solutions to reduce it, or I wouldn't say find ways around it, but to be able to have private partners get to commercial phase sooner or faster?
Good question, and that's actually one of the few things I, as a manager, can help to achieve. The old system, the current yo-yo system, is a proprietary system built according to a spec that is really, really old. So that's not the road we want to travel. We're public, so we're not. It's difficult for us to be dynamic. There are ways we use förkommersiella upphandlingar. Some Swedish there. Sounds very fancy. We've also developed a laboratory, which is now situated in Malmö Sea, where we're trying to bring together business development, our legacy systems from Hässleholm, where we're situated, where there's a lot of data and information. And on top of that, we are developing our own systems. So we are actually become software developers. Now, this might be considered crazy, but the truth is the public transport sector is the same all over the world to a certain extent, but there are very, very specific regional differences which have to do with laws and customs and so on. So you can't actually buy a proprietary system and expect it to be the same, universal. So it will be highly adapted to your local rules and regulations. And as you can imagine, this sort of binds your hands behind the back. So in this way, we can develop exactly what we need. And we're doing it on the basis of being able to share information, make it, it's modular. We're doing it with lots of small, short projects, a very agile set. And this means that our organization has to work in the same way. We have to have our public procurement processes have to help us handle this. So there's a lot of management issues behind the scenes that have to be solved and resolved to be able to create a situation where people like Love can have fun and create great solutions.
And if we know exactly what we want from trials, I mean, if we have a short, very detailed requirement list, then I guess the procurement process would be quite short as well. We just hand out an A4 paper and say, this is what we want.
Yeah, but we don't know what we want.
Yeah, procurement. I don't know if that ever can be short, but that's another question. But thank you very much. I think we might return to you a little bit from the panel's perspective. Thank you again, and we can talk more to you guys during the mingle, and a big hands of applause again. Thank you.